All right, so let's try these. So remember, we are looking for the forms to use L'Hopital's rule are if you have 0 over 0 or an infinity over infinity. Okay, so let's look at the first one. So again, you're kind of cycling back and forth. You're saying at first I'm checking by putting in the input number, and then I'm deciding what to do. So if I check it first, I'd have, if I put in 3, sine of 3 pi plus 3 minus 3. And then I only have 9 minus 9. So this is 0. And when you're on the axes, the sign is 0. And this is 0. So it's 0 over 0. So we're like, okay, we're going to use L'Hopital's rule. So we're going to say this is the same as the limit, except now we're going to take the ratio of the derivatives. So it's cosine of pi times x times 3 plus 1. And the derivative of negative 3 is 0. And then you would have 2x. Okay, so now we're going to check again. You ready? Okay, so let's check. The cosine of, put in 3. So we have 3 pi times 3 plus 1. Whole thing over 2 times 3. So we know we couldn't use L'Hopital's rule anymore because we've got a 6 in the denominator. Okay, so this is 6. Cosine of 3 pi is 1, 2, 3. 1, 2, so I think that's negative 1. Oh, I times that wrong though. I think it should be times, this is times pi. Messed up on my derivative. Okay, so that works. We get a number then. So what's my number? Negative 1 pi plus 1 over 6, which on a multiple choice, they probably write 1 minus pi over 6. Whew. Okay, let's do the next one. Okay, so remember when we were talking about integrals? Okay, if we put in a 0 here, we'd be going from 0 to 0. So that gives me 0 for my output because I'm not evaluating anything. I'm not accumulating over 0. So we can use L'Hopital's rule. Okay, so that's the limit as x goes to 0. Oh, remember the sign we have in the back of our room? That is the second fundamental theorem. And we're going from a constant to x. So the derivative is just the integrand evaluated at the variable, which is x. And in the denominator, the derivative of x is 1. So I think now we can actually just input 0 because I know I won't have L'Hopital's rule because I'm dividing by 1. So I should be able to figure out what the limit is. Okay. And the cosine of, put in 0. The cosine of 0 is 1 over 1. So my answer is 1. Okay, let's look at the next one. Okay, so now we've got x is going to infinity. So I know the denominator goes to infinity. And the numerator is an integral. And if I sort of think about that function, t squared minus t is t times t minus 1. So it's this parabola, plus 1. It's this parabola opening up. And as I integrate going forwards, the area is going to get bigger and bigger and bigger. So this is infinity over infinity. So I can use L'Hopital's rule. Okay, so the derivative of this, that's the second fundamental theorem again. Away from my dog, somebody's out in front. Tink, tink. So the derivative is just the integrand evaluated at x. So it would be x squared plus x over the derivative of the denominator. So 3 times 3 would be 9x squared plus derivative of 2x is 2. And now we could do L'Hopital's rule again, or you could remember from pre-calculus that this is the ratio of two it's a rational function. It's the ratio of polynomials. So we can look at the leading terms and think about their behavior. And at the end, they behave like 1/9. This has a horizontal asymptote of y equals 1/9. The limit is 1/9 as we get bigger and bigger. Okay, let's see this one. Whoa, derivative in disguise. So let's do this 2 ways. This is f prime of pi over 6 when the function is, so you can see the function shows up twice. So sometimes it's easier just to look at this. It's like this function, but instead of the input, it's x. So f of x is sine of x, which means f prime of x is cosine of x, and f prime of pi over 6 is cosine of pi over 6, which is little wedge, which is root 3 over 2. And you get the same answer if you do L'Hopital's rule, because it would be a 0 over 0 format. And you would get the limit as h goes to 0 of cosine of pi over 6 plus h over 1, which is cosine of pi over 6 plus 0 over 1, which is the same thing we have, root 3 over 2. All right, we haven't done a table for a while. You ready? Okay, so let's check. Okay, so put in 0. You're looking for f of 0 over g of 4. You put in 0 for x. F of 0 from the table is 0. G of 4 from the table is 0. So you know we can use L'Hopital's rule. Okay, so we're going to write a new ratio and try and take the limit of that. So the derivative of f is f prime. Keep the input, baby chain rule. The derivative of g is g prime. Keep the input. Now be careful here because the derivative of 4 is 0, but you're subtracting x. So we have to remember the -1 multiplier. Okay, now we're going to check, and my bet is that we're not going to get 0 over 0. So let's see. F prime of, so now we're putting in 0. 3 times 0 is 0 times 3 over g prime of 4 minus 0, which is 4 times -1. Let's look at the table. F prime of 0 is 2 times, we need that 3, and g prime of 4 is 10 times -1. So it's -6/10, which is -3/5. Yes.